Okay, let's get started. You ready, Noah? I'm going to do the intro.
Ready to go.
Okay. All right. Well, thank you everyone for joining us for another online meetup. Very honored to have Noah here coming to discuss Amazon Web Services Lambda. He's quite an expert in this area. If anyone had a chance to look at his page in his GitHub, there's a number of resources from classes to Jupyter Notebooks to everything. So I really think that if you're interested in this area, you're going to learn a lot from this talk. So before we get started, I'd just like to go over a couple things, thank our sponsors, and just talk about upcoming events really quick, and then I'll hand it over to Noah. So for questions, I will monitor the Zoom chat room and the YouTube chat. So I know some folks are on YouTube, and then I'll bring them all together, and at the very end, I'll ask Noah all the questions. So to get started, my name is Jason. Again, thank you. Our sponsors have stuck with us throughout the COVID stuff. Really, they're allowing us to do this, paying some of the costs and just helping us secure some of the speakers. So Varon Technologies has been with us for several years. They're an innovative consulting partner, doing a lot of work with DoD. They actually do have work in Maryland, Virginia, Georgia, and Hawaii. So if you're in any of those locations and you're looking for work, please reach out. You can always contact me and I can put you in touch with the appropriate person. Clarity Business Solutions is a defensive contractor in the Maryland area. They do a lot of data science and analytic work, solving complex business problems. If you're interested in learning more about them, please talk to me. ICF is a larger 7,000 person company. They do a lot of cybersecurity. They do a lot of work in Fairfax, in Columbia, and Rockville, Maryland. And they do some work out in San Francisco. They do a lot with data science, data analytics also. So if you'd like to work for a larger company, let me know. And then this is my company, Areas Ventures. We're smaller. We're only at 5, so that's quite smaller than ICF. But if you're interested in learning more about what we do, let me know and we can have a chat. We do have a newsletter that goes out. It went out yesterday. It usually features some interesting articles. I try to put local stuff in when possible. It has some recent stuff about COVID. And we have a meetup scheduled for 2 weeks that's going to be on the blockchain. So if you're interested in that, please join us. And with that, Noah is the founder of Pragmatic AI Labs. Like I said, he has a ton of material out. If you look at his website, if you look at his stuff, there's a lot of things to look at, from courses to articles to books. So I think he definitely is an expert in this field. Again, for those that joined a little late, I will gather all the questions through the chat and then we will ask them at the very end. So with that, I'm going to hand it over to Noah.
Sounds good. Yeah, thanks everybody for showing up here. One of the things that, I guess I'll just talk maybe 30 seconds about my background. So I'm a consultant and also a lecturer at a few different universities. I'm in the Raleigh area, North Carolina. I teach cloud computing at Duke in their data science program, their MIDS program. And it's pretty interesting that the university system is really starting to get into the cloud. And that's really the area that I specialize in, is I would say cloud computing, but also how to take machine learning models and also data engineering systems and just build things that work. Some of the courses that I teach at Northwestern, which is another place I teach at, is really focused on, can I take a computer vision model, convert it into a real production system and get it to work? I feel like that's probably one of the bigger challenges that's happening in really the machine learning data science area, is that there's a lot of experiments. And I think the COVID-19 scenario is really going to shake out a lot of the inefficiencies that have been happening. I wrote an article about a year ago, I think, or maybe a year and a half ago, called Why There May Not Be Any Data Scientist Job Titles by, I think, 2030. And what my reasoning is that I don't think being an experimenter is really a job title. It's more of like a capability, to investigate, look at data, do explorations. At some point, you have to actually add value, ROI, to a company. So that's kind of my mindset is really focus on, if it's not in production, really it isn't doesn't count. And then also cloud computing is really the area where the majority of the work is happening. If you think about machine learning, you're not using machine learning on your laptop. It's just, these are toy problems. You're going to be using the cloud. You're going to be using a data lake. So that kind of gets me into the topic that I'm going to talk about today, which is that I think maybe 80% of people that are in data science right now, maybe it's exaggeration, maybe 50 to 80% haven't really developed a cloud story. And so what I'm going to cover today is how to, from ground zero, set up a cloud environment, start writing Python code, getting some continuous integration set up, and basically just bootstrap yourself and become a cloud developer, and make sure that it's a capability you have. And one of the things that I'll also cover is that what you do on your laptop is very different than what you do in the cloud, because the cloud tools are actually designed to work with their cloud ecosystem. So that's a little bit of my background, the way I think about the world, and hopefully this talk will inspire you to get super motivated on using cloud computing. And by the way, I use AWS, I use GCP, and I use Azure. Really I don't care which one. I like all three platforms. In this particular talk that I'll do today, I'll talk about AWS. Yeah, and I guess one other thing I'll do as well is just share my screen here and get started. And I'll also just briefly talk about the book I just recently wrote, Python for DevOps. It has been fairly well received, and it's in a way really kind of a sneaky way of saying, basically get machine learning into the cloud. That's another way of saying a lot of the topics that I cover in this book, and that's how we actually got introduced for this meetup. So to start with, let me just briefly show you this resource, which is if you go to GitHub, there's Noah Gift is my handle, and there's a link here to AWS Lambda. And I just want to talk really briefly about what you could do in a cloud that you can't really do in your laptop. And one of the things you can do in the cloud is that you can actually get in to building really sophisticated systems with just a little bit of code. And let me scroll down to this particular diagram, which shows you an example of something that you could build in under an hour or so. So let's say, for example, you wanted to build a scraping application that talked to Wikipedia, grabbed information about some particular topic, and then you wanted to run that periodically, do some kind of natural language processing on it, put it into a database, and then turn it into maybe a machine learning model that you do a prediction on, and then you build a production system around. One way to do that is to build a serverless AI data engineering pipeline. You could have a timer. The timer would be a producer. The producer would scrape use AWS Lambda to scrape, let's say, Wikipedia or an API like Qualtrics or whatever, some data source. It would then put it into DynamoDB, and then it would go in. I'm sorry, it would read. You would have all the different data sources listed in DynamoDB. It would then read the output and put that output into SQS. And SQS is a queue that really you can't break. It's infinitely scalable. So you could put thousands and millions of messages into SQS. And then on the other side of it, you have the consumer, and that would be a Python function, a Lambda, that could get fired off, and it could go through and then do some kind of a AI app operation or a machine learning operation, and then put the results of that into some location. So this is really a new style of working, where a lot of the problems with Python in particular have been that Python has some severe issues with performance. Python has severe issues with scalability, with parallel computing. But by using the cloud, really, you don't need to worry about those items, because you can think of the cloud as a new operating system. So that's just kind of a preview of why it's so important to know about cloud computing and some of the things you can do. And this is actually a really, this is actually a real world example of an architecture that I've used in consulting projects. For example, like I built a natural language processing system for a law enforcement organization that used this kind of a style. And again, with one person, you can build something that maybe previously, if you didn't use a cloud, could take maybe a whole team of people. And I think that's one of the big takeaways. So let's actually talk about what it is that you would do to set up your own environment and kind of get started. What are the components that you would use? And I think what I can do here is I can go to Sketch.io and just kind of draw this out real quick. So let's say you want to start from zero and you want to build out a Python-based machine learning pipeline or a Python-based development environment in the cloud. Well, what would you need? Well, I would say the first thing that you would need is you need to have like a Git repo set up, and we'll do this in a second. Set up a Git repo. The second thing is I would make sure that you have a cloud environment set up. So we'll call this AWS. And then the other thing that you would need to get set up is also a CI system. And so there's a lot of different CI systems. You could do, GitHub Pages. You could do, GitHub Actions. You could do Circle CI. You could do Amazon Code Pipeline. Whatever randomly pops in my mind, I'll pick one of those and we'll set this up. But the idea here is that you have this feedback loop instantly that goes where you can be checking in your code on AWS, and this would be Cloud9. I'll just call it C9 just because it's easier to write. And this feedback loop is constantly checking your code. And once you got this cycle set up, then you can start building out data engineering pipelines, machine learning pipelines. And so this is really, to me, the most important step. And if you want to see some of this in more detail as well, there's a link to, this is called Cloud Data Analysis at Scale, and I'll put this into into our chat here. Jason can kind of propagate that on other channels. But this particular website has a bunch of this stuff in detail, like how to set up from scratch Onboard and go through that. So if there's something that I don't cover in as much detail as you'd like, you can just click on one of these resources and you'll see a bunch of stuff about like screencast and how to and everything. So let's go ahead and get started here. And the first thing that I would do is, again, just set up a Git repo. So let's just go to GitHub. Let's spin one up. So I'm going to say new repo here, and we'll just call this Onboard. There we go. And I will say this is an AWS Lambda. I'm sorry, AWS Cloud9 Lambda Onboard. And what I typically do is I will put a README file in there to start with, and I'll also set up Python git ignore. And I like this because it will get rid of like junk files that are kind of irritating. So step one, there you go, create this onboard repo. Step two is I would go to AWS and go to my console. Now I'm assuming here that you have a free tier account set up, which is pretty easy to set up. You just put your credit card in there. You can essentially use AWS for free if you do it right for years and years and years and years. So I'm assuming you have an account. I'm going to go next here and I'm going to just type in Cloud9. And this is, I think, one of the stealth tools that most people don't know about on AWS. That's really, I would say, one of the best things that's available. So I'm going to go ahead and say create an environment. We'll go through here and we'll say onboard again. And this is my development environment. There we go. And then from here, you can actually, if you want to use the free tier and never spend any money, you could just leave the defaults. And the defaults are actually pretty good. It would create a new EC2 instance. It would give you a micro instance, which really is probably good enough for most things that you're working on. Now, if you are doing like Docker container development or doing parallel computing or doing some kind of machine learning, training or something like that, then maybe you do want to get like a bigger machine, and you can get really large machines. Like if I went through here and I went to, I don't know, like here we go, 192 gig of RAM, 48 core machine. You know, like you can get pretty beefy boxes here. So just for fun, let's, I don't know, we'll pick like a big machine. Like here we go, 32 gigs of RAM. I have a bunch of credits I need to burn. And then with Amazon Linux, I would recommend that you stick with that, even if you are an expert in Ubuntu, which, you know, I like both Amazon and I also like Ubuntu. But because Amazon Linux is their default platform, it's just going to be an easier workflow, in my opinion, especially if you haven't been doing this before. And then next, I would say next step, and then just say create environment. So what's cool about this is you can set up as many of these as you want. And also, unlike with the EC2 instances, if you've played around with EC2 instances, it'll auto time out. So if you go away from this thing, it'll just shut off the machine for you. As long as you're not running like a background process or something, it'll just shut down. And then every half an hour or so, you could wake it back up again. So it really solves this problem of in a way, you can use a more powerful machine than you could afford on your desktop, and you're developing natively in the environment that you need to deploy the software to. So I think this is probably the future of software engineering, is that people are going to use these cloud-based environments. So let me just walk you through some of the goodies that you get here by default. So one of the things that you get by default here is the AWS SDK is already installed, right? So if I say AWS S3 LS, I can list all of my buckets, right? So basically I have a really powerful machine that's sitting right inside of the environment that I'm developing in. And also if I wanted to copy data back and forth, this is going to be an ideal scenario versus syncing S3 data to my laptop or something. I mean, which depending on where you are, it could be very, very painful. So just the data sync alone is great. Again, as I mentioned, because Cloud9 is designed to work with the AWS ecosystem, you already have access to every single SDK call through AWS tools, which are pre-installed. Also Python, right? If you want to do some Python development, you know, if I just say Python 3, you can see Python 3 is already installed. So it's pretty much ready to go. And again, it's a Linux environment. So the first thing I typically do when I'm setting up a AWS environment is I would go back to that repo, which we set up, which is Onboard, and I would say clone or download, and I would grab this link. So next up, what I'll do is I'll do a git clone, and this won't work. There'll be a problem. So there we go. Uh-oh, don't have access because I haven't set up SSH keys. Again, you can do this very easily by just setting up SSH keys. So let's go ahead and do that. I'll type in SSH-keygen-t RSA, create some SSH keys, and then I can just link that into my Git repo. So I'll go ahead and do that, cat this, and then from here, I can just paste this in to my GitHub account by going to this corner up here, and then just going to profile, and going to, actually not profile, to settings, and then going to SSH and GPG keys, and then just creating a new key. And you only have to do that once, the first time you set up your environment. And then from then on, you've got access to that Cloud9 environment. So we'll call this one Onboard. There we go. And it'll ask for a password. Go ahead and do that. And now if I go back here and I do a clone again, it should work. So now I've got already something pretty useful set up, which is I can read and write data back and forth. So, you know, to even test it, you know, I could just double click on this file, which is Markdown, which is, I'm sorry, not that Markdown file, this Markdown file. And I could put in, you know, like, hi, there we go. And then let's go ahead and update this. So I'll say git status. So I'm not in a Git repo, so I need to cd into that onboard directory. And then I can do git status. And then I'm going to say git add readme. And then just do a commit. Say adding hello and we'll say, when you first set things up too, you'll want to configure your username and email address so that you have tracking. I actually am really big into statistics with Git. So let's go through here, and then I'll just put in my email address here as well. Let's do that. Okay. And then I'll also do an amend here. And then I should be able to go ahead and save that. So there we go. We'll write that out. I'll exit, and then I'll do a get push. And then if I go back here, we should see that onboard directory that I've verified that I can edit it. So I'll go to repo here, onboard. Here we go. So let's see. There we go. You can see the word hi is there, right? So I was able to update it. You can see the last change was made 25 seconds. So we got some bidirectional, secure communication in there. So that's step one. Now, what I typically do when I start writing code in Python is that I also will create a virtual environment, and the virtual environment protects you so that you don't have to, get into this really weird scenario where you're chasing your tail with packages are in one repo and packages are another. So I create a convention where I will create a virtual environment that's the same name as the repo that I created, and I put it in my home directory. So what I do is this. So I say Python 3-m-v-env. So make a virtual environment, and then I do this convention tilde.onboard. So basically, for me, if I use the same convention each time, it's simple to remember what to do. So basically, I know that anytime I create a new repo, I'll create a new virtual environment, and they're the same name, right? And so it's just really simple, and I don't have to think about how to activate that virtual environment. So there we go. I create the virtual environment, and then what I'll do is I'll source it, and just go like this. Take that. Oops. Take this here, and then do bin activate. So this is kind of the hoops you jump through to, step one, create it. Step two, source it. Now, if you're really lazy, and I do this a lot, is I'll also even go into Bash or Z shell, and I'll create an alias, and then I just automatically source it when I shell into an environment, and then I don't even have to worry about it. So how do you verify that it works? What you do is just say which Python, and you should see that the Python now lives in that that location that you set up. So that's pretty good to go. Now the next thing that I would do to start developing something would be that I would maybe just make a Python hello world script, like a command line tool or something like that. So I have a repo that I had set up before, which is a Python DevOps course. I'll put this into our chat, and I'll just grab something out of here, like let's see, a make file. So I typically like to create a make file, and I'll show you that real quick. So let's go here. I'll just kind of cut and paste this and throw it into our repo. So I'll go and I'll do this. I'll say touch make file, and then this is where you get the benefits of using the cloud-based environment. If I go to makefile here, I can just paste this in. And one thing I'll also recommend with makefiles, if you see this as spaces, change that to tabs. Say convert to tabs. There we go. Makefiles are more friendly with tabs here. And so what I can do is just kind of tweak this to my needs. So I use that as like a template. I just kind of copy and use the same style. And generally here, you can see that requirements is one of the ways that I typically install packages, and I put it inside of a make install command. So I upgrade pip, and then I also do a requirements file. So what I'll do next here is I'll type in touch requirements.txt like that. And then inside the requirements file, what I will do is put in whatever packages I need to install. So typically the three things that I typically install in almost every project is I'll do like PyTest, I'll install PyLint, and then I'll maybe like click for like building a command line tool. And you can also pin those and do all that stuff. Just for speed, I'm not going to put specific versions of all that stuff. So There we go. And once I've got that set up and I save this, now I've actually got this really simple convention also that makes it really easy. Every time I work on a project, all I have to remember is source the virtual environment, which is the same name of my repo, and just type in make install, right? And if I go through here and I say make install, it's just really simple. Every time I run my project, kind of all the logic is hidden away into this make install command. So to me, this is 20 years of using Python. I've gotten to the point where I just want to make things super, super simple. So now that I've got that set up, I really have this great little feedback loop where I could build a command line tool and maybe try something out. So again, I'll go back to a project where I have, let's say, a click command line tool, which is this DevOps course project. I don't know, let's just grab one of these, like, sure, that looks good. So I'm going to paste this into a repo here. So we'll just say touch, and we'll just call this, let's call it hello click. That looks good. Hello click.py. And I can build out a really simple kind of test application here. And just a couple of things I'll point out. I do use Click extensively. It's by the same developer that made Flask. And what I like about Click is it's really a function-based system where you just put a Python function, put a decorator on top, and then it's a command line tool. And I just like that style of thinking. In Flask works the same way. It's a function, you put a decorator on top, and it runs in a web service. So in this case, I put a shebang line on top. So pound, exclamation, user bin, env Python. I import Click. I put Click command here. I have a function in here that says hello world, just to change it, just to make it different. Hello world, I am live streaming, right? And then all I have to do is put this syntax here, which is if under name under equals main. That tells this script that if I'm executing it from the command line, go ahead and call that function. Otherwise, if I import it, it won't do anything. And now Click does all the magic. So if I do this, and I then chmoded +X to make it a real command line tool, then I don't even have to use Python now. It'll know how to grab Python from the environment, and I can do // and then do hello click, just like that. And then if I want to be really tricky here, I can type in help, and Click will automatically add a bunch of help stuff in there, right? So it tells us really what's available. And if I wanted to build out a really sophisticated command line tool, you could see all these different options here. And if you look through my GitHub repository, I have a ton of stuff I do in Click, and you can see really huge Click applications I've written. So from here, let's go ahead and just run this, and you can say, there we go, hello world, I'm live streaming. So I've now got a Python app running. So what would I typically do next here is probably get lint working. So just to make sure that my syntax is correct and I'm not making errors and things like that. So next up, what I would do is look at the lint. And what I typically do when I set up a lint is that I disable the recommended and the configuration linting, because I just feel like they're useless noise, and I keep warnings and errors. So the way I do that is I say pylint -- disable equals R, (C). And then I think the other thing, yeah, I think that will work. I might have to add one other thing. We'll test this out, but now I can run make lint. Let's see if this works. There we go. So I've got perfect, score. And one of the things I can do as well is actually test it out to make sure it really is working correctly. And if I put like a bad variable or something, like if I say var equals, right, that's an undeclared variable. Well, will it actually catch that? Let's go ahead and try that out. It blows up. It says line 4. That's correct. It even tells me the characters. It says, right, this is 1, 2, 3. Right at character 4 or character 5, right? It says line 4, character 5. There's a problem. Now, if I fix that and I just delete, if I just comment this out, then the lint should work again, like that. Make lint. Right. So to me, I've already got a pretty powerful setup here using this convention-based approach with a makefile, right? I have make install and a make lint, and just this alone, I think, is a lot of people don't do this, and just doing this is going to massively help your project. So the next thing that I could set up would be also to set up, I guess, coverage, and then also I could set up a test as well. So let's go ahead and do that. And I will go and run this tool here, which is, I will set up, I'll make a test file. So I'll say touch test hello, and we'll just do like that. And then I can, again, go back to this repo that I had looked at earlier, just kind of mimic something I'd set up. Let's see, I have a test file here, and I'm just going to kind of just tweak this a little bit. So go back here and go to this test file. And the main takeaway here, okay, now I know one thing that I messed up on, which is, because I'm going to test this, I should rename this. So I'll just move this, you know, instead of saying hello click, I'll just do this. I'll just say hello click. Just take that hyphen out of the middle there. I'll say move hello click. Just essentially rename this thing. So we'll say hello click to just, there we go. It makes it so that importing doesn't get messed up here. So, and then if I go back to the makefile, we'll say close tab. Let's just double check that that still works. And again, this is actually one of the things that linting is great at, is to make sure everything still is kind of functional. Great, that works. Now I can actually tweak this test script here by using the click runner and also import things. So I can say from hello click, and then I could look at something I can import and test. So I could go here and say hello. So we'll go ahead and import hello. So we'll say hello, and we'll say test hello. Let's do that. And then when I invoke it, I don't need to actually do anything, because there's no commands. I'm making intentionally like a super simple script. So I think I can just do this. I can just put like an empty list maybe, or even, I wonder if I can just do nothing. And then basically we just say, does it work? Hopefully that works. And then I could say make test, and let's see, make test. And oh, I need to tweak my makefile here. I had like the wrong stuff in here. So I'm going to say this, and I'm going to say test hello, like that. So again, because I use these same things, I just kind of tweak things that I've set up before, and you have access to that. So now that I've done that, let's say make test, there we go, I passed. So we've basically got linting, testing, installation setup, virtual environment setup. And then if I wanted also test that the functionality is correct here, I could again, you know, basically, you know, I don't know, make this break or something. So I could do this. I could say var equals, and just add like a bad syntax in here, and this should blow up the test as well. So we go here and I say make test, boom, it blows up. So we've got two checks here. We got like business logic checks, and then we also have linting checks here all set up here. So now what I would do is go ahead, I'm going to push this code so that other people can get access to it. So I say get status, and you can see there's 4 files created: makefile, a Python file that's command line tool, a requirements file that has the packages, and then also this test file. So this is really the I would call it the boilerplate needed to have an application running like a Python project, like a best practice. So let's go ahead and do that. So we'll say git add star, and then we'll say get status, and commit here, adding a starter project. So what else could we do to kind of take it to the next level? The next level would be to also get continuous integration set up. So how would we do this? I think the laziest way is that I'll use GitHub Actions. So GitHub Actions, I think this repo here might have it set up here. Let's see, do I have GitHub Actions set up here? No, I have Circle CI there, but I do have a project with GitHub Actions. GitHub, I'm gonna look at my repo here and find one real quick. So repositories, and we'll look at GitHub Actions. Yeah, GitHub Actions PyTest. So I'll put this into our chat and you can see this as well. And so what I will do is that you can see that it has this like GitHub workflow style thing. And so I'm just gonna basically copy this and then I'm gonna have that in my buffer, and then I'm gonna go back to my project, which is this Onboard project, and I'm gonna set up GitHub Actions. So why is this important, and why does it tie in so well with something like Cloud9 is that the beautiful thing here is that I could have like literally like I'm renting a laptop at the library. I could be, you know, like at a friend's house. Everything that I need to develop software is in the cloud somewhere. So the development environment is in AWS, and then the continuous integration. This could be a production-based system, all using SaaS-based providers and web browser. So I think that's the beautiful thing about this kind of a setup. So what we're going to do next year is I'm going to go ahead and set up a workflow. And I think what I can do is I can say Python. Let's go ahead and say, yeah, this one, set up a Python application. And it's going to give me like kind of like a recommended style of you know, setup here. And this is pretty good, but I'd already done this before, so I'm going to just tweak this. I'm going to put my version of it, which is a little bit simpler, and I'll make it a little bigger so you can see it. But basically what this does is, in this case, sure, I'll use Python 3.8. They're very similar, Python 3.6 and 3.8. And I will install the dependencies, which will be step one. And again, what's great about the makefile is that it simplifies the, you know, when you set up your build system, you don't have to do anything different than when you set up your development environment. You just know that there's three things that happen: make install, make lint, and then make test. And then later you can do a make deploy. And I feel like this is one of the ways to just make your life so much easier and to set up continuous integration and continuous development. So again, here we've got, you know, make install, make lint, make test, right? These are all things that we all set up. So it should be ready to go. If I just say start commit, and we'll say set up continuous integration like that, then this should go through and set this, this thing should build automatically for us. So what I could do to test it is that I can just basically bump the code. So I can go over here, do a git pull, and it should grab some, yeah, the new files there. And then maybe what I'll do is I'll just intentionally break it. So I'll take this variable. That's one of the ways I like to test something, is intentionally break it. We'll say git status, git add this, and put breaking the code here, like that. And we go back to this Onboard project, and you'll see that the Actions tab, if I click on this, that it will be queued up. There we go. Now you can see it's in progress. I can click on it, and I can see this thing doing what, you know, basically going through the actions. There we go. It's installing the dependencies. It's going to blow up right here. There we go. So error. So it blew up. So it's great. We actually have something that's working. Now, what I typically like to do as well is actually put like a Git badge there. So I think what I can do, if I go back here, it's got like a, yeah, here we go, create status badge. So I'm going to go ahead and copy this. And then I'm going to go back to the markdown here, and I'm going to edit it and just throw this at the top. And I'm going to show you a neat little trick that you can do as well. Once you've got the cloud-based continuous integration set up, I do this all the time, and I did this when I was CTO of a company. I would actually write code in GitHub because I was very confident in the continuous integration and continuous deployment I set up. So we can fix the code right here without going back to Cloud9. So we know what the error is, right? It blew up. So what I'm going to do is I'm going to go to hello click here, and I'm going to fix the code right inside of GitHub. So I'm going to go to this, and I'm going to go like that, and I'm going to use GitHub as an IDE. And then it's going to re-trigger the build. And if I go back to GitHub Actions, it's going to be running it again, and we should see it fixed this time. There we go. It's queued. It's in progress. I can click on it, look at it, installing the dependencies again. And then this time the lint should pass. It did. And now we've successfully got a build. And then if I go back here, this badge should update back and forth with, I might have to tweak that. What did I, why does that look? I think it takes a second for it to warm up, but anyway, I won't get into the making the badge work properly. It looks like it's probably working, but in a nutshell, this is what I do for most projects I set up. And again, we've actually worked pretty quickly. This didn't take that long, but now I've actually got a safety mechanism built into my project, and I can actually go back here, do a git pull, and it should pull in those changes. And then I also can verify that now the changes work here. So if I type in fact, make all, and let me just show you what that does. So a lot of times the all command is something I use because these are three things that always need to happen: is double check that the packages are updated, double check that the linting works, double check that the testing works. And it's kind of like a sanity check. Like every time I work on a project that I haven't worked on for a while, or I'm working on somebody else's project, I just do two things. I just basically say get pull, and you could even automate it. You could say and make all, right? And if those both should work. There we go. So get pull, there's nothing, make all, install, lint, test, everything's good to go, right? So this is really, I think, the minimalistic Python setup for AWS Cloud9. The other thing that maybe we probably don't have time to go into too much just because of the time limitations, but I'll show you really quick is for Lambda, if you want to start setting up and developing Lambda apps, let me just show you a couple things about that. So if I go to, let's say Cloud9 real quick, or I'm sorry, AWS Console, and you want to get into doing something with Lambda, what I would recommend if you've never done anything with Lambda is first just try it out from inside the console, and then I'll show you how you hook it into Cloud9. So what you can do is just create a function, hello world. We'll just call this thing onboard. And runtime here is I would pick Python runtime. I like to pick an older one like Python 3.6 because the Cloud9 is still a little behind. So I want to pick the same Python that Cloud9 is on. And here would be where you would set up execution roles to allow it to do other things like talk to SQS or talk to SNS. So you definitely do need to do this if you're going to talk to other parts of AWS. And this is probably one of the most common ways people make a mistake on AWS is they don't set this up. I'm just going to create like a toy application, so I'm not going to do anything there. But once you click it, it'll open up a console that allow you to actually develop software inside of this web browser. So let's should take just a second. You can see it gives you this designer pane here, and then it gives you an editor. So one of the ones I like to build is this thing called Marco Polo. It's kind of like a Hello World app. So what I typically do is that I will take this out, and then I will say if event name is equal to Marco, return Polo, otherwise return back no. And I can take out this JSON. We don't need that for now. And then basically all this is a really simple function that takes in an event, and the events in Amazon Cloud9 could be anything. It could be SQS, S3, but in this case, it's just going to be a JSON payload. So what I'm going to do is I'm going to save this, and then I'm going to create a test for it. So I go here, I say configure test event, and then I'll just say, call this one Marco. And then I'll just take this out, put in name like this, and then we'll call this Marco, and I'll save it. And this should fire Polo. So if I say test, it'll pop up. There we go. We can see that it set up Polo. And then if I want to create a one that doesn't work, then I'll go through here, and then I would create a new one, and we'll call this one Bob. And then this one will say Bob. And go. Now go ahead and create this. And then if I run Bob, it's going to say no, got nothing for Bob. So this function is not a friend of Bob. So that's kind of how I play around with using things with Cloud9. Now it could do all kinds of stuff like build serverless web applications, all kinds of stuff. So that's why I feel like a lot of the stuff that people in Python were really evangelizing is basically dead. I think web frameworks in general are pretty much a waste of time, because why would you use something that isn't designed for the cloud? Instead, just use the native tools for the cloud. It just doesn't feel like it's worth backporting all that stuff into this. Now, if I go back to Onboard here and I want to play around with this, how do I play around with that Lambda function inside of Cloud9? What I can do is click on resources, and then you can notice here has remote functions. I can actually go here and I can right click on it and say import, and it will let me actually start editing that function right inside of my Cloud9 environment. So this is another kind of killer feature that this thing has that I'm a huge fan of. And now what I can do is even actually edit it locally. So if I right click on it now, I can say run local, and basically I can test out the same thing. So I can go through here and say, name is equal to Marco, and run that. This should work in theory. There we go, Polo. And if I change it to, Johnny or something like that, this should not work. And another thing I can do that's pretty cool is I also can go back to this and change it and redeploy it, which is, I think, one of the killer features of Cloud9. I've actually used this on commercial projects where I've worked with like 4 people, and we actually can pair program inside of here. By the way, you can actually go collaborate and invite people, and you can all pair program together in this environment. So to me, Cloud9 is like one of the best things that nobody knows about on AWS. So what I'm going to do next here is I'm going to add a print statement that just prints the name of the event. Actually, I don't want that line. I want to just print it so that I can debug it, if there's a problem with it. So I'll just go through here, add f string, and say this is my event, and I'll put the f string syntax here, and then go like that. And now I save this. I can now also again go back to this and debug it, just make sure it works before I deploy it. So run it local. Okay, let's see. And you'll see that it adds like a print statement now. This is my event, which is now I'll show you why that's so important. So if I go here, I can just right click, deploy. It's going to deploy this. Let's go back to our environment here. If I refresh, it'll pop up here. There we go. And there we go. You see the print statement. If I test Bob, look, we see that this now has a print statement. Now, why is the print statement? One, it's helpful to just look at it in the console, but the other thing is in a real world production environment, you need to have logging. And so now I can actually look at the logs. And if I click on view Cloudwatch logs, you'll see, in fact, these logs now pop up, right? So this is invaluable to debug things. So in a nutshell, hopefully what I showed you was how simple it is to set up a Python environment from zero, and then also how simple it is to start creating Lambda functions, importing that into Cloud9, start coding against it, and then setting up a real world environment. So that's basically a good stopping point. I don't think we have time to go into this, but the next step would be then you could build something like I showed you earlier, is build this. And if you want to take a look at this, there's a bunch of videos that you can check out, and there's a whole like how-to guide on how to build a more complex system. But this is a good stopping point, I think, to just show you, how quickly you can build something and kind of go from there. So also, before I guess maybe I go to some questions, if you go to Leanpub as well, and I'll put this in here, I have like a ton of stuff. I've been like writing tons of books simultaneously to this. If you want to take a look at some of those, I have a lot of this kind of stuff in there as well. So those are some of the ways to get a hold of me. And yeah, maybe what we do now, and you can also look at my website. I have a lot of stuff as well. You can look at some of the stuff that I've got up there. But yeah, maybe it's a good spot for maybe it's a good spot for time for questions potentially.
Sure. Yeah. So if anyone has any questions, just type it in. I'll capture them and moderate them. So I had a question from
Sure.
So where do you see like data science, and I know you do a lot with AI and machine learning. Like, how does that fit into this platform? Like, are you using notebooks? Are they integrated into Cloud9, things like that? Can you talk about that as some?
Yeah. So I would kind of divide things up into two sections, which is you've got the data engineering, and then you've got the machine learning. And the data engineering side, I think Cloud9 is, I would say it's probably always going to be there. It's almost like you should think of Cloud9. Let's only talk about AWS for a second. If I was developing real world machine learning applications with AWS, I would always have a Cloud9 instance running somewhere that does some of the stuff, because it's like your laptop, except for your laptop's way faster and it lives in the environment, and I can use it to copy data back and forth, try things out, all kinds of stuff. And then if I'm going to build a data engineering pipeline, a lot of times the serverless stuff, like what I was showing, you would start to get more complex and put in, timers, and maybe talk to serverless, bigger systems like EMR or AWS Glue or Athena, and those would do all the head, or Kinesis, and those would start doing the processing. And I think that world works really well with the Cloud9 world. Now, for machine learning, I would recommend using SageMaker. And with SageMaker, you build out a Jupyter notebook, you start going through, start doing training. With SageMaker as well, it actually can spin up and provision, let's say, 20, 40, 50 nodes and do a distributed training job. When it's done, it'll automatically get rid of those machines. And then you can save that model into S3, and then AWS SageMaker, the endpoint itself can also auto scale, and it can refer to that model. And then you could constantly be building new models, and those new models, you could be A/B testing them with SageMaker. So I feel like that's another mistake that many students that I work with make, or maybe people new to data science, is that the software developers are less likely to make, which is they start trying to roll their own solution. I think is a very bad mistake. Is whatever platform you're on, if you're on AWS, use SageMaker. If you're on GCP, use AI platform. Use the platform and start building stuff on top of their platform. So I think AWS, I would see two components: is you have your data engineering pipeline, you have a machine learning pipeline. In both cases, use the platforms that are available. Don't do it yourself.
So is SageMaker similar to like Google Colab, I think it's called? Like, is it basically like a cloud-based notebook platform?
It's similar, except for the fact that in addition to doing notebook hosting, it also does distributed training, and also will host your machine learning endpoint for you. So it's an end-to-end solution for a machine learning application, where Colab is just a hosted notebook.
So where does, can you talk a little more about the Lambda? I'm not as familiar with it, and I've tried to read a little bit before this, but there was a question about like, what role does the Lambda play to the entire project?
Yeah, I think, so as I mentioned before, I've been using Python close to, actually more than 20 years now. And with Python, there's all these problems that it has that are very irritating. And one of the irritating things is that it's very slow. There's no compiler. They have this global interpreter lock that is no matter what people say, it is a big problem. When I use other languages, I don't have to worry about like, oh no, the threads don't work on all the cores. But with the cloud, fortunately, we got lucky that it completely eliminates that, because you can write a Python function, and the Python function with Lambda directly maps to every single thing you can do on AWS. So you can build async distributed workflows by responding to events. For example, let's say you have a bunch of images that get put into S3. You could have a Lambda directly associate with it, and then that could be a trigger. So basically, it's a building block for, I would call the cloud an operating system. It's like the new operating system. And instead of having threads and processes, you have things like queues and Lambda. And Lambda is basically infinitely scalable. So you can have tens of thousands, hundreds of thousands of Lambda functions. And even better, it's event driven. So the events can actually, you can respond to events. So that's really where Lambda fits in. It's almost everything you would ever do on AWS, you can associate with it in an event driven way with a Lambda.
So I'm new to a lot of this, so it's of course a little overwhelming. And with AWS, there's always a ton of options there. But what is like the pipeline? Like, you went through the basic setup. Like, if someone wanted to get started, that's listening, and wanted to do some like a data engineering side project, like where would they start? Would they out of the gate want to be working with Lambda? Would they want to be using the other things that you mentioned? Or
Yeah. So the link that I gave that has the project called in GitHub NoahGive/AWS Lambda, I would say that would be the place I would recommend starting, is build a serverless data engineering pipeline first, so that's the quickest possible way to get something done. And I've actually designed the data engineering capstone for Northwestern's graduate data science program, and that's actually one of the capstone projects is this exact repo. So you can feel assured that if that's essentially like a graduate level data engineering example. And I think the serverless is really important, because with serverless, you can build things really quickly and get a feedback loop running. Now, the next level above that would be, I would use something like Athena, and Athena can directly talk to S3 and grab a bunch of data out of it, and you can use a data lake. But I think just getting started, I would take that project that I showed you and just walk through that project, and that will get the light bulbs going.
So do you think there's any risk of building on top of these platforms? I mean, there's always people will do their own thing, homegrown, or bring together different products that they have on the open source. I mean, do you see pros and cons to that? Are you worried at all about that? Or
I personally am not that worried about it, because I feel like the bigger problem is getting something done. So the bigger problem I see is that like most of the problems in companies and most of the problems in software teams is really execution. Data scientists, really the problem is execution, is that you had an idea, you didn't execute it, it's not working. And to me, that is worth the trade-off, is to use a cloud provider to execute quickly and get something done. Now with the cloud providers, I think if you are worried about locking yourself in, I think the best strategy would be still use the cloud provider, use natively the tools they offer, but also make sure that you're an expert at least one more cloud. So that's really my strategy, is I use all three clouds and I feel comfortable in all three clouds. And I don't feel like, if one of them turned nefarious and was like jacked up their prices 100 times, then I just leave. And then I wouldn't feel worried about, moving something to a different cloud. And I think the fact that there's so much intense competition that it makes me less worried. I think the alternative to not using the cloud native tools is to use something like Kubernetes. And there's a lot to like about Kubernetes, but it feels like potentially a solution in search of a problem for many companies, in that you have these two choices. Hey, can I build something really quickly? And then the other one is, or I can adopt this massive complexity that I may or may not need. I don't think that's a great strategy, is to not build something and then to immediately embrace the most complex solution that you possibly can pick. That I've seen it happen in my career a lot. Like, for example, the classic one is the C++ versus Python example. Is I cannot tell you how many people I've worked with in my career. They're like, well, we can't use Python because C++ is better. It's like, you're right, it is better, it's faster, got better performance. But meanwhile, I just built an entire company in 2 months working part-time, and you're still trying to get code to compile. So you're right, it's better, but I'm faster and I'm already done. So I think it's a pretty good comparison.
So a lot of you mentioned this a little bit, you use all three clouds. So a lot of the stuff that you showed, like the Cloud9, are there equivalents on the other clouds?
Yeah, so AWS has Cloud9, Google has Google Cloud Shell, Azure has also a Cloud Shell. So basically, that's the other thing that's nice about this is you can rest assured they all just copy each other. So it's just a complete copy fest. So like AWS Lambda, Google's got Google Cloud Functions. Like I think it's a great time actually to use a cloud because they're all ruthlessly competing with each other. Prices are going lower. Each one's copying the same functionality. So it's actually very, very good. Anything you can do on one, probably the other one either can do, or it's gonna adopt that new offering.
So there was a couple other questions. There was one, does Lambda fit in a container or outside containers, or both inside and outside containers?
So all Lambda is basically a managed container. So it itself is just AWS putting lipstick on a container and making it easier for you to manage. So Google Cloud, their version of Lambda, which is called Cloud Functions, you can modify the container and actually tweak it. So I feel like, maybe since the last time I checked, you can also tweak that with Lambda. You might be able to, but that's what I think is going to happen with a lot of these platforms, is that might be more where the container story comes into play, is that you can customize the runtime. But with Google Cloud, you can actually, it is basically, these cloud functions are basically just containers that they put an abstraction on top of. And then in the case of Google Cloud, you can actually modify the runtime and actually change it and put your own container in there.
Okay. So I guess in the description, we talked about step functions on the meetup page, and then you had SQS. When would you use SQS versus using step functions? Is it a choice of one or other, or might you use them both in a project?
Yeah, you could use them both in a project. So the step functions, the place that they come into play would be that you can orchestrate multiple Lambdas together, and you can actually create a workflow. Just from a time perspective, it probably wouldn't have been wise to get too much into it, but just a high level, like you saw the Lambda function, you put an input in, you do something to input and return it back out. That's kind of the concept. With a step function, you add another layer on top. And so with a step function, you can write in JSON, basically the way to orchestrate several layers. So it could be, grab something in, do some kind of processing to it, wait for an event, if it's true, then call this one function, AWS Lambda function. If it's false, call this other AWS Lambda function. So basically it's like a state machine. And then with SQS, where that fits in handy is for handling something where you want to develop an asynchronous workflow that has potentially infinite scale. So where I've used SQS is that I will have a Lambda function directly fired. So it's a one-to-one. So basically, as fast as you can put messages into SQS, your Lambda functions can fire. And so it's actually a great parallel computing mechanism. And one of the things I developed with it a few years ago was a jobs pipeline for a computer vision company that was building a VR platform. So we would spin up a bunch of machines, like 1,000 machines at once, spot instances. Those would wake up, talk to SQS, grab something from SQS, process it. When it's done processing, delete the message from SQS. So it works really well in that kind of a paradigm where you have a big, giant distributed computing problem, either with AWS Lambda or using a heavier weight machine like a spot instance.
There we go. Sorry, I was muted. No, that was great. So you had mentioned, when people you always see that the holy wars between languages and analysis paralysis and getting started and everything. So I guess I was curious. There's always articles about, Python's dying or Python's losing steam, and I just read one and it's talking about Go and Rust. Are you seeing those other languages being supported in things like what you're showing? Like, can you do similar stuff using another language?
I think Go is probably the one that is got the most traction, I think, for cloud computing, and that all these cloud providers typically also support Go. Like AWS has good Go support, GCP has good Go support. I think the key issue here is that and I'm actually not a Python zealot. I actually stopped using it for several years because I was just bored of it, and I switched to other languages. But I feel like the problem with Python the reason it's not going to go away is as someone who's not like a zealot towards it, I actually don't care. Tomorrow I would switch to different language, is that it's just too effective. It's that it's the second best language at everything. So it really is good enough. And the libraries are so large. And the biggest problem is, and one of the reasons why I was basically going to never use it again, was performance. But it doesn't matter in the cloud, because the cloud handles the concurrency problem for you. And then if you turn, and what Go really has, which I like, there are two things that I think Go is really good at, is it has the binary, packaging, which is really, really awesome, which kind of you don't really care about as much with cloud computing because it lives in the cloud anyway. And then the second thing is it's faster, but again, the execution speed in many cases is not that big of a deal with something like Lambda, because you're designing these stateless machines. So I think Go is actually very awesome language, and I've played around with it a bit and done some stuff with Go, and I like Go. It's just, I think, unfortunately for the Go, if you want a one to win over the other, is I just don't see the compelling use case being, for the things that it's better at, it isn't enough, I think, to displace the speed of of how quickly you can build stuff in Python. That's really the thing Python has going for it, is just how quickly you can build stuff. I think something like Swift is, I think, maybe something that could beat Python as its own game, which is that you could probably write code just as quickly with Swift. I have written some things in Swift, and it has the advantage of having type inference, a compiler, So I think if you could, the way to beat Python would be to be as quick at developing things and have it also the large of an ecosystem that it has, and then make it better, like have a compiler, have type inference. So I think Swift maybe Swift has a better chance than Go of displacing Python, but I don't see in the next couple of years, especially for cloud computing, there's just not a massively compelling use case, in my opinion, to use another language.
So there was a couple more questions kind of related to this. I think there's a lot of interest in choosing the right platform, the language. So if someone is already in the process of moving from Java to Golang and doing Lambda with Go, are they missing anything? Or, I mean, do they still need to learn Python, or is there any gaps there? Question.
Yeah, I mean, I don't think there's anything wrong with Go at all. Like if a company's using Go and they're proficient at it, I don't necessarily think there's a reason to switch to Python. I think the other part about language adoption that's important is, who do you know, and then what's the market for developers. So I think if you pick a language like Rust, for example, or Haskell or Erlang, I developed a whole company using Erlang for several years. The problem is that nobody uses it. So I think it's a very bad idea to build a company on a language that nobody uses. The Go, though, there is a lot of adoption. So I don't think you're going to go wrong with Go. I think the part that could be an issue is that if your company's using machine learning, you're probably going to have to use Python. So then if you are going to be using Python and Go, it's like, well, now you actually have made I call the second language a permanent tax for the history of the company. So as soon as you add a second language, and I've made this mistake as a CTO, I put like 3, 4, 5, 6 languages in a company. Every language is like a permanent tax forever, because some developers in a company will never learn the second language. And then when you hire, now you have to hire for 2 positions. So ideally, the dream scenario is you have one language and you do everything in that one language, and your velocity is going to be much, much quicker. So if you're not doing anything at all with machine learning, then, and you're already doing Go, like, yeah, what, I mean, I don't see a reason to use Python. In fact, I don't think there's really that big of a difference. But if you are doing machine learning and you have all this Python code already with, like, I don't know, I don't necessarily see the reason to just adopt Go just because it's got it compiles and like the execution time is faster, unless you were building some specialized tool. Like if you were building, let's say, an agent, and the agent was like collecting data from an EC2 instance and performance was important, and you were building actual servers, then yeah, I would not use Python to build servers. Like, I think that's a horrible idea. But most people aren't building agents that run on a machine. I mean, there are some people that do that, but that would be, I think, a clear case where, yeah, I think Python, I've built companies that did that, where we wrote servers in Python. I think servers on Python are just horrible, horrible idea. Just the performance is just very bad.
Yeah, that makes sense. No, that was a great answer. I like how you brought together both the technical and the business thinking about, you know, your choices. So I guess there was another question, because you talked about the 3 platforms. Is it still the case where you kind of have to develop each one separately, or are there any solutions that allow you to kind of develop once and go across platforms? I know they tried to do this some with like the mobile. There's certain things that you should be able to make applications that would work both in iOS and Android. I don't know if there's anything similar for the cloud platforms.
Well, the company that seems like the 2 solutions that seem like they're addressing this are, one is Terraform. Has this concept of building infrastructure that works on both clouds, and they also have, that same company is part of, it's called HashiCorp. They also have things like Nomad, and you can run jobs on multiple platforms. So that might be one solution. If somebody they really were able to define the problem so that it was like a jobs execution problem, then HashiCorp, using their tool chain, that might be one way to handle it. The second one would be Kubernetes is actually cross-platform. There's solutions for it. The hosting, you know, Google has GKE, Google Kubernetes Engine. Amazon has EKS. You know, Azure has their own Kubernetes engine. So you could use Kubernetes, and then that could definitely be the way to distribute jobs across the platforms. I would be pretty skeptical for a startup to use that, unless, now if you were building like a continuous integration company like Circle CI, then okay, Kubernetes I think would make a lot of sense, right? Because you could kind of play the cloud vendors off of each other, and what you're selling is compute time. So then that would make sense to have that complexity. But if you're just building like a SaaS app or something, or like a, you know, some kind of CRUD app, and then you put in Kubernetes and then try to deploy it to all 3 clouds, I think that's a big mistake. I think it would be like, again, like picking like 4 languages and just hoping that for the best, and like proxying back and forth between all those languages. I don't think the complexity initially would be worth it. But if you did need to do it and there was a use case for it, I would say Kubernetes and also HashiCorp are probably the 2 leaders in that area.
Okay, so I think this is the last question. So, you know, obviously you're an expert. You did an amazing job going over everything. I was in awe watching you navigate that so easily. You have a ton of material. So there was a question that kind of bleeds into something I wanted to know. Can you like briefly just give an overview of some of the books that you wrote, and like, you know, where would you get started? I mean, I looked at your page and you just have a lot of material and you have a lot of courses. Is there anything that you would say start with? Like, I know you even have like the Pragmatic AI, which goes into a lot deeper with like machine learning and how to utilize those. You know, for our audience, it kind of mixes between data scientists and software engineers. So, you know, can you just go over where really would you want us to start? And like, are there any of the books that we really should be ones, or the ones that we just focus?
Yeah, I think if you go to, I guess I could maybe just share my screen real quick, just so I can point them out. So if you go to Leanpub here, these are some of the things I'm working on like really quickly, and I'm probably gonna chill a little bit this summer because like I have to be careful of blowing myself up. But I did just finish 2 books one called Minimal Python. I think if you wanted to get up to speed with being you saw kind of how I build stuff in Python. If you want to just be super effective with the minimal amount of Python, this I think was probably be the first place to start. It would be Minimal Python. And then maybe right after that, you could do testing in Python. And this covers a lot of, how to build testing, gets into more complex scenarios. And then I would say maybe book 3 would be this, the DevOps in Python O'Reilly book, which is here, which is DevOps. Python for DevOps. And this one is actually kind of hit a chord with a lot of people. I think it's a lot of the reviews are saying that, hey, this is actually hitting exactly what I was looking for. So I would say that would be like, book 3 is like how to actually do stuff, DevOps. And there's a lot of cloud, a lot of, Lambda functions. And then after that, I think the next one would be then I would either the Python command line tools, which we're almost done with, we should be done probably into this month, or cloud computing, either depending on which direction. If you're not doing a ton of stuff in the cloud, then maybe you could wait on that. But either one, this one in particular is something that is based on the course that I'm teaching that I taught at Duke, data science program, and it's close to being done. And it covers AWS, Azure, and GCP cloud, and has a bunch of screencasts and all kinds of stuff. And actually, I'm a bunch of I also teach this material in China, and they're actually going to translate a version of this book. So this is a kind of, I would say, one of the hotter areas. You could start with this just if you're only going to kind of focus on the cloud as well. But I think that might be a, if you had the time, a good one to go to. And then if you're interested in, this is more of like a consulting type book. This is one of the other things I'm working on this summer. Is it's funny because I wrote this book, or I started to write this book way before the pandemic. I started in December. And the idea, this is basically how I've made a living as a consultant, is that I think of things as red money, yellow money, and green money. And with red money, that's you having a job. And I think most people, if I said this before the pandemic, people would go, yeah. They wouldn't listen as much. Now people I think would listen, is that working for someone is actually not as safe as you think it is. It's actually very dangerous because you have all your assets invested in one location. If you do consulting, you can actually design your lifestyle so that you have many different clients. And if one of them goes away, it's not that big of a deal. So I think even employees should consider having a little bit of consulting. But if you're a consultant, the recommendation I have, and I talk about this, is that you should never put no matter how much someone's paying you, never do more than 25% in one client. It takes a lot of discipline to not do this, but otherwise you're basically an employee, and you're actually, it's even worse because they have all this leverage over you, can drop you like that. So I would always have that 25% rule. Then the other thing I would recommend is that you also start getting into doing things that are green money. So, investing in stocks, selling products, writing books, and that's eventually where you want to go to, is that when you get into things where you're selling something versus selling your time, it's infinitely scalable. But when you're an employee for somebody or you're doing consulting, you're essentially at the mercy. You have to ask permission to make more money. But when you're investing in yourself and you're investing in your own products, you just ask yourself, do you want to make more money or work on things? So that's kind of the concept that I cover in this book, and I should be done with it in the summer, but this is kind of my summer project.
That was awesome. Thank you, Noah. So
sure.
I think that's it. I think we're going to wrap up. I mean, I think you did an amazing job. That was really great. I thank you so much for doing this. If anybody is interested in any of the books, the links are there. If you want to get in touch with Noah, reach out to me. I can make the introduction if he doesn't mind.
Sure.
The video will be available on YouTube. His GitHub is available. And I hope everyone can join us for the next meetup. So stay safe. Thank you, Noah. Thank you very much. And if you ever need anything, just let me know. Have a good. All right. Thank you, everybody.
See you later.